All right, well, welcome back. We're going to do another application problem. In this case, we're going to use law of cosines and good old traffic controller problem. Yes, you find a lot of these when you're talking about physics. You use the law of cosines, law of sines a lot with vectors and whatnot. And whenever you deal with rates of change, if you get into calculus, you'll deal a lot with these types of problems. But many of the times they are also right triangles instead of cosine or sine or oblique triangles like this. So in any case, we have aircraft tracking. To determine the distance between two aircraft, a tracking station continuously determines the distance to each aircraft and the angle A between them. All right, so basically two aircraft, you got an angle A, and they're tracking what's the distance between them and that opposite side from A, little a. We're asked to determine the distance of little a between the planes. Given angle A, given this angle right here is 42 degrees, and we are given B, which we know is 35, and C, which is 20. All right, and we can kind of see that. We drew it out. We have a picture. And so from here, we are given side, angle, side. Side, angle, side, we're asked to find this side right here. This is obviously going to be a law of cosines problem, law of cosines problem. And so how do we solve law of cosines? Well, we know that given the opposite angle to a side and the two adjacent uh, sides to that angle, or to make up the terminal initial side of that angle, we can use law of cosines, and we'll use that right there. We know that A is going to equal the square root of B squared, which is 20 squared, plus 35 squared, minus 2 times 20 times 35, times the cosine of, in this case, 42 degrees. We put this into our calculator. We find out what the answer is. You can do that right now. And so when you put in your calculator, you should get something like so. I took the square root because when you look at this, you have to get A by itself. So you have to take the square root of the entire side. We are only taking the positive portion because we're looking for length. Make sure that you do close cosine and you do put a minus sign and multiply it through that way. We press enter here and we have 24.178. 24, so A equals 24.178, and that is going to be in miles, and we'll label this miles. That is how far those two planes are from each other in this particular case. Not too bad. All right. Law of sines, law of cosines are very, very useful when you're talking about oblique triangles. And like I said, are used a lot in physics, vectors, also not a little bit in calculus as well when you deal with oblique and non-right triangles as well. All right. Well, hope this helps you out. We're going to have some more videos on how to use the law of cosine applications coming up, so you can look for those if you need more additional help. All right. Good luck and God bless.